Hello, today I would like to cover set covering problem, which is on the distribution network. For this problem, I uploaded the data set on Canvas. So in this problem, I have camera locations. As you see, I named these camera locations from 1 through 15. I have 15 camera locations. These are possible locations for me. And also I have here 20 stadium areas. So imagine that I would like to set up cameras in this stadium, and there are 20 segments in this stadium or 20 areas in the stadium, and I named number them from 1 to 20. So this is my given data, and as I told you, I like to start my problem with the given data, and then next, I always ask myself, what is my objective in this model? So let's um, let's see what my objective is in this problem. So let's type the objective. Again, this is my model here. I would like to calculate the objective function value. What am I trying to achieve here? So my objective is minimize cost. But in this case, because there is no monetary figure, I assume that every camera that I install will cost me money in terms of labor cost, in terms of camera cost, maintenance cost, and so on. So I would like to minimize number of cameras installed, right? I would like to minimize number of cameras installed so that I can minimize my cost. Again, I will calculate this value using Excel solver right here. But to be able to calculate this, I need to define my decision variables and constraints as well. So next question is uh, install is my decision variable. So maybe I can put that decision variable somewhere right here. My decision is whether to install cable these cameras. So I can just put it here, and then let's highlight this area as yellow because I don't know the values of these cells, but I know that these are my decision variables. Right? Beautiful. So I have my objective, I have my decision variables. Now I can calculate my objective function value. And in this case, my objective function value is minimize number of cameras. So literally, I would like to minimize the sum of these values that are going to be calculated by Excel solver, right? That's good. Currently, I have 0. Now I need to define my constraints. So my constraints, again, will have left-hand side values and right-hand side values. So I'm trying to decide where to install these cameras. So what I can do is, again, I can copy the stadium areas here and then maybe paste it somewhere here. And then once I have these values, as you see, I have stadium area 1 through 20. Maybe just I can drag it left a little bit. Okay, since I have a merge cell here, let me unmerge it first. Let me just put these values one cell right. Beautiful. So okay. So I would like to make sure that I don't violate my constraint. So I have 20 stadium areas. I just put them over here, 1 through 20. I can merge this. All right, and I would like to decide whether I'm going to install cameras in these locations or not. Again, constraint should have 3 components. Left-hand side, which should be calculations. I will have relationships, and then I will have right-hand side, which should be given. In this case, what's given is that every single stadium area has to be covered by at least 1 camera. So by at least 1 camera, that's why I put everything 1. And since it's at least, my relationship here will be greater than or equal to. I may have multiple cameras covering the same area, so I need to have at least one camera covering that stadium area. So that's why I put here greater than or equal to 1. So now I need to calculate these left-hand side values. To be able to calculate this, I want to make sure that whether the stadium area 1 is covered or not. So to be able to understand that, I need to use again some product function that will multiply the coefficients here with their corresponding decision variables. So this may sound a little confusing. I may give some examples here now to explain better what's happening. For example, if I install the camera 1, which is 1, and either you install something or do not install something. So if I install something, that means it's 1, then all the others will be 0. This is just a hypothetical example to explain. As you see, camera 1 is installed, but camera 1 is not covering the first stadium area because 0. But if I put camera 2 installed instead of camera 1, you will see that my value here is 1, because if I install camera 2, that will cover the certain areas such as 1, stadium area 3, 4, 5, 7, 8, 16, 17, right? And since the area 1 is covered by camera 2, if I install that, then I will get the coverage. So I would like to copy this formula right, but I cannot just copy it right because I need to make sure that when I drag it right, I want this blue array to follow me. I want it to move to right as well. But this red array, I want to stay constant or the same location. To make sure that that's not following me, I will highlight my red array and then press F4. So that will add dollar symbols in front of the letters and the cell references and numbers so that that array won't move. Press enter. Now I can drag this formula right. Now you can see that if I install again only one camera, that will cover certain areas. But again, I don't know the values of this. I could put any number here to start with, or I could leave it blank. So again, these are my constraints. I have 20 constraints for every single stadium area. So let me just put a reddish color here. Now my model is ready to run. So let's run my model using Solver. Again, if you don't know how to use Solver, please go to Options, File, Options, Add-ins, then you hear Analysis Toolpack Add-in, and then click Go, and then make sure the Solver add-in is checked, and then click OK. Once you do that, under Data tab, you have Solver, and here I need to define my objective. My objective here is minimize the number of cameras. So green cell is my objective. Again, it's a minimization problem. And my decision variables are my yellow cells. So I will highlight these yellow cells. And my constraints, I have only one set of constraints that has 20 constraints in it. My left-hand side value in this set of constraints is right here, these values. I want to make sure that these values are greater than or equal to my right-hand side values, which are these values right here. So if I click OK, now I have 20 constraints or one set of constraints. I would like to make sure that my decision variables are non-negative. That's why I check this one. We always use linear programming. Click solve in this class. So as you see, Excel could find the best solution for me. Click OK. But as you see, there is a problem here. The problem is that I'm installing partial camera, and I know that that's not possible. I cannot just install half a camera. To eliminate this problem, what I'm gonna do is again go to Data, Solver, and here I will add another constraint. Click Add, and then I will say to Excel Solver that these decision variables cannot be partial, or in other words, they have to be binary, 0 or 1. So if I click OK, now I have another set of constraints telling that these values have to be either 0 or 1. If I click solve, that will solve my problem, and I got my result. Perfect. So I need to install these cameras. Which ones are those? camera 4, 6, 9, and if I install these 3 cameras, which is the minimum number of cameras, I will cover all my areas. As you see here, every single area has at least 1 camera coverage. So that's it for today. Enjoy supply chain management.